All right. Two things. First off, do not cheat in my class. I will catch you and I will fail you. Do not submit the wrong packet tracers to me. Do not try to cheat by downloading them online. I don't care if you're on medicines. I don't care if you're going to have surgery. I don't care what your excuses may be. I don't care if your grandmother has pink eye. Don't download it. You're not learning. You're here to learn. You're paying to learn. You're not paying to cheat because you're not going to be able to cheat in life. You cheat in life, you can go to jail, you can get fired. I want you to learn, and I want you to be able to prove it to me, because what's going to happen is on your final exam, when you have to go to the library, to the testing center to do your final exam, for those of you that are online, you're going to be watched to do your test. So I would highly encourage you to pay attention to know what you're doing, okay? Because downloading the answers are not going to help you. Second thing, when you submit your packet tracers, do not zip the packet tracers. If you zip them, I will not grade them anymore. I will give you an automatic 0. I will not let you resubmit them. I do not want to uncompress them, because I have to uncompress it to open up your packet tracers, or else when I open it from the zip file, I just get a blank packet tracer. Well, what does a blank packet tracer tell me? It tells me you didn't do it, so I'm going to give you a 0 anyway. So if you want a 0, fine, then zip it, because I'm not going to be able to open it. So that's a heads up. It's out here. I'm giving you the benefit of the doubt now. Anything prior to now, I'm grading. But as of 5:51 on the 6th of March, done. Is it the 6th or is it the 5th of March? 5th of March. As of right now, anything that's come in after now, if it's a zip file, you're getting a 0. No questions? Your midterm has now been posted. You have 10 days to do it. It is due at 11:59 p.m. on Saturday, March 15th. It's an open book, open note. You'll turn it in to the Dropbox. If it is 1 minute late, you will receive a 0. I will not accept a midterm late. No excuses. You have 10 days. You're all healthy right now, so I'd advise you to get it in as quickly as possible. Don't wait till the last minute. Because if you wait till Saturday and then you get in a car wreck on the way home, whose fault is that? You know what I'm going to say? What did you do with the previous 9 days? And I guarantee you the school will support me on it. You're all grown adults. Y'all know better, right? So I'm going to start treating you like adults. We're going to have fun, but I'm going to treat you like adults. Got to hold you to some expectations, however little they may be in my class. Come on, y'all can laugh about that. Where's Todd tonight? All right, maybe he got stuck at work. All right, we're going to cover chapter 1 in the routing, start of the routing book, even though I know y'all don't have these books. All right. This is where we're going to start talking about how to do routing commands. We're going to talk about protocols and concepts. We're going to talk about how we forward packets and things of that nature. We're going to identify a router. We're going to demonstrate the ability to configure devices and apply addresses. We're going to talk about the routing table, and we're going to determine or describe how the router determines the path and switches packets. We're going to talk about what the purpose of a router is. So what is it? What is the purpose of a router? Kevin? I can't hear you.
Send packets along the network.
Okay. Anthony, you want to add any more to that? No? Boy, y'all are just really killing me tonight. Cole, what do you think? Besides just sending packets across the network, what else does a router do? Well, yeah, it forwards it, but it gives it the direction. It provides the route and says, okay, let's say you come to a fork in the road. Okay? The top of the diamond. And then at the midpoints, they can come back down to go to point C, right? Or point D. If you go to the right, you go to point B. If you go to the left, you go to point C. But both B and C will actually come back down to point D. Which one is going to be quicker? That's what a router does. It routes the traffic to the least cost or the quickest route. That's what it does. It finds that pathway for those packets to traverse. Routers typically have two different types of connections. They have a LAN connection, which are going to be your fast Ethernet ports, right? And then they have your serial ports or your WAN ports. Sometimes they're BRIs or T1 CSU DSU ports. Those are the, or you may have some fiber ports. Okay, those are going to be your WAN type connections. They connect directly to your ISPs. A router is basically sends the data from between 2 points, point A to point B. That's all it does. All right. Think of a router as a point-to-point destination. That is all they act as. They're not a multi-point like a switch. Aaron, you look confused.
No, visualize it.
Okay. A switch, you can have a 24 port, a 8 port, or 16 port, 48 port, right? You have that one port that comes in. You can have 48 ports going out, right? That's a multi-port. Where a router has one that comes in, and then it has one that goes out. I mean, basically that's what you'll come into. You have a very small amount. Now, it can have multi-ports that go in and out, but they're only directly linked to one other object. A serial will be connected to another serial. Fast Ethernet will be connected to another fast Ethernet. Those fast Ethernets will be connected to switches. It's not going to be connected to a ton of fast Ethernet switches. You could have 2, you could have 4. That's about as many as you're going to have. I've seen some Ethernet modules that have 8 on there. That's about as many fast Ethernet ports as you're going to see on a router. Okay? So, routers can examine the packet's destination by looking at the IP address and then determining by its routing table which way it's going to route that traffic. All right? For example, if it says that it's directly connected via the WAN interface or the serial 00 for the 192.2 address, this packet is going to somewhere on the 2 network. It's going to go out that serial interface to go to that router 2. Does that make sense? We talked a little bit about that a few weeks ago. What is a router? Well, we've already talked a little bit about a router. It has a CPU. It has RAM, ROM, NVRAM, and flash memory. Those are its 4 types of memory. RAM, ROM, NVRAM, and flash memory. Then you have your interfaces, whether it be serial, BRI, Ethernet, fast Ethernet, in management, whether it's console, auxiliary, all right, terminal lines. Here is basically what you're going to see. You're going to have a couple slots. You have a couple fast Ethernets. Here you have your NVRAM. You have your RAM. Flash memory, compact memory, your CPU, your system bus. You have your console port, your auxiliary port. That's basically the internals of your Cisco router. You want to know how it boots up, right? Well, starts out with ROM. It does what we call POST, power on self-test, right? Y'all remember how computers boot, right? Power on self-test. Then the ROM handles the bootstrap. It loads up the bootstrap program saying, okay, how are we going to load our operating system? It looks in Flash to locate our operating system. If it's not there, it needs to go to TFTP server to upload it. It'll go there. Then once it does that, got the operating system says, okay, now we need to load our configuration. Looks in NVRAM. Is it there? No. Okay, let's go to TFTP server. Is it there? No. Then we can go to the setup mode. And then we can go to our console. Console is where you actually do all your entering of your information. Okay? Everyone with me? Have put y'all to sleep yet? Okay. Y'all will need to know the processes and how a router boots up for your final exam. Ugh. I'm tired. I'm yawning intentionally to put y'all to sleep. Oh, come on now.
It's working well.
Cameron over here is about to fall asleep. Did I? I just saw your eyes going, oh. And Kristen, you're wide awake. Oh, you got candy, that's why. All right. Here's how the router boots up. First thing it does is it looks at the iOS. Or you look at the iOS. Look at the version number. Tells you what version you're running. ROM tells you what bootstrap version you're running. Here's where it tells you what processor you're running and how much RAM you have available. Here it tells you how much, what type of interfaces you have, fast Ethernet and low-speed serial, how much NVRAM you have, and how much system flash you have. You'll need to be, if I ask you any of these information, if I give you this segment and I say, okay, how much do I have, you need to be able to tell me. Beware of the pop quiz. And everything went quiet. Okay. Here's the WIC 2T. Daggone it, I forgot to bring those in again.
Pineapple?
No. WIC 2T. Pineapple's for NetSec.
Oh, you said you were bringing it here
And then I have the two fast Ethernet ports, the console port and the auxiliary port. These are LAN interfaces. That's a WAN interface. Remember packet forwarding? All we do is look at the destination and source IP address to figure out where the packet's going to go. Routers operate at what layer? Which is what? Network layer. It only helped that it said right here, right? How many of y'all saw that and said it? Be honest.
I did not see it.
I didn't see it either.
Yeah, I just...
Sure. What layer do the routers operate at?
1, 2,
1, 2, and 3.
I saw that. All of it.
Well, because he's got to push all the packets down to the physical bit to be able to send them on. They're normally a layer 3 device because they can go up to the third layer. That's why they call them layer 3 devices. Okay. Implementing basic addressing schemes. We've done a little bit of subnetting to figure out how to address them right. Device names, interface names, IP addresses, gateways. Basic router configuration, you're going to have a router name, right? Where do you do that at? Doing configuration terminal, right? Banner, passwords, interface configurations, you do all that in the configuration. So basic configuration would be under config T, right? You're configuring. If you're going to configure an interface, here's some configurations that you need. Some basic commands that you want. Show IP interface brief, show interface, show IP route. All these right here are going to be in your configuration. Okay, most all your commands are going to be in your configuration area. When you have a show, you're going to want to be in your privileged mode only. All right. You want to make sure that your port is always a no shutdown so that it's always on. If you have a static route, you're going to be setting up, and it'll tell you, you'll see this by looking at it with the S identifier out to the left, it'll say static. Make sense? You see this S here, SC means it's connected, a direct connect. Why do you want to use a static route? Brent?
When the network consists of few routers.
You always know what machine is what IP if it's a small network.
Cody? I'm going to start throwing erasers.
Because if there's only a few routers, then if they're static, then there's not any other place they can go. I mean, if everything's set.
A static is when you don't really have any direct connect, you only have one router. And all you're doing is saying, I need to go over here to this. You're trying to help supply a direct way to get to one place to another. Okay? You could have two routers and you may or may not see each other if you don't have any default routes set up. Dynamic routing protocols, network discoveries. Those are nice to have the automatic discovery. That's when we get into the routing protocols, RIP, IGRP, EIGRP, and OSPF. We're going to get into those a little bit later, where you'll have OSPF, EIGRP, RIPs, RIPs2, so that you can actually see what's going on. All right. Basically, three ways that a router has to worry about routing tables. Based on the information in the routing table, every routing table can be different, and a routing table can how to get that route back, or for it to come back. Okay. I mean, you can tell it how to get there, but it can't tell it how to get back. Does that make sense? It's only saying, here's how you get to the next hop. So here's a tabletop exercise for you. Packets can take path X, but cannot return via Y. So if I'm sending a packet out PC1, which path is it going to take? It could take a lot of paths, right? But it's not going to tell it which way to come back. Because all it says is a source and destination address. That's it. MAC layer, all it does is say what my destination MAC address and my source MAC address is. That's it. Pretty simple. A metric that we talk about is a hop count. How many different hops is it going to take to get there? All right. How many different times does it touch a router before it gets to my destination? Before I'll let this packet just drop off. So if I give it a hop count of 30, it can hit 30 routers before it's done. Bandwidth is also the speed of the length, right? So if I have a T1 here, a T1 here, and a 56K, if my packet's coming here to this router, which one is it going to traverse? Is it going to go here and kill 2 hops, or is it just going to wait to come here for 1 hop? Maybe. If this is congested, it may just wait to go here, depending on the frame size. You may have some that come here and then down, some that just go here and down. But now, if we have what we call an equal cost load, let's say all these are T1 lines. So you may have one go here, one here, and just keep going back and forth, back and forth. That's what we call equalizing or load balancing. So, one of 3 path determinations. We can do a direct connect, we can do a remote network, or we can do no route determined. So which one do you think will this be?
No route determined, because it hasn't determined the route yet.
Exactly. All right. The switching function. When a packet gets to a switch, it strips off the layer 2 header, puts on the next layer 2 header, and sends it on. Strips it off so it can see where it needs to go, puts on another one, and sends it on. That's all it does. Pretty simple, right? Trying to think of a good example. Take a Tootsie Roll. The outside of it says Tootsie Roll, right? Pull it off, open it up, it's a Tootsie Roll. Put it back on, it's a Tootsie Roll, I pass it on. If I open it up and there's a piece of double bubble in there, that's not a Tootsie Roll. I'll toss it in the trash, right? Make sense? As the packet travels through it, the IP address will never change. The source and destination MAC address will change as the packet traverses. Why? Because the MAC address is at layer 2. Remember, layer 2 is on the outside of layer 3, so when I strip off the MAC, sees, oh, it needs to go to this one. Well, that's going to go out to this next MAC address. Here's my MAC address, and sends it on. Does that make sense? Each time it goes to the next router or the next switch, it's going to get that next thing. All right. PC1 sent it to router 1. router 1 then sends it over to here. We're examining it here at dot 2. Dot 2 says, okay, I'm here. I've stripped off the first header of it because I've already got it to here. My MAC address is OB31. That's where it needed to go, right? It came from here to here. Now, the source address is going to be whatever this is going to be. And so it can send it on over to here. And then we get it on over here to, it was the OC22. Because that was the source and its destination was the OB20. Right? I can't even read it. Yeah. But that's how it goes. Each device strips it. It just moves it from the destination to the source and adds in the next hop. Does that make sense? It strips it so it can see where it's at and then makes itself the source. Any questions? So what we're going to do as we get on, we're going to start talking about static routing. Next week, and I'll start getting into the commands on how to do the static routes for you. And we'll start going in through the command line interfaces for you, alright? Make sense?
Yep.
Actually, I'll probably start that after spring break. So we have Monday and Wednesday, right? Wednesday, y'all will do. I want everyone that's in here to have your midterm done by Wednesday in class. So you'll do it in class on Wednesday. You can start on it beforehand, but you'll do it have it done in class on Wednesday. And then, how many of y'all are done with up through 11? How many of you are close? My fear is if I just start going over this before spring break, y'all will forget it. Because I only have 10 chapters left. And it ain't going to take me that long to go through them. As you know, I can go through 3 chapters a night. Y'all like this speed I'm going through? Would y'all want me to go through the rest of the book for you? No. 2 more books for you before the end of the semester?
Maybe not.
You sure?
I'm pretty sure.
I'll just give you more packet tracers to do.
Well, in that case.
Then you won't have anything to do in advanced routing. No, we'll call Monday a lab night. Okay. So you can come up here, do your labs. If you don't have any labs to do, you don't have to come. But you have to be here Wednesday night for your midterm. Alright? What's the matter, Anthony?
My son's first soccer game is that.
Well, then come do your midterm on Monday. It's open. Come do your midterm in here on Monday, and then you can go watch your son on Wednesday. Yes, Kristen.
So essentially, could we do the midterm on our
Fine. Come do your midterm on Monday and then take Wednesday off. Since everyone seems to want to do that, just come in here on Monday, do that, and then we'll give you a lab day on Wednesday to catch up. But even though everything's due Saturday, right?
Hopefully you'll have us then by Wednesday.
Well, everything's due Saturday, isn't it? So that wouldn't really make a sense for you to have a lab day, would it? Midterms on Monday then, and I'll give you Wednesday off. How's that sound?
I don't know.
Midterm is on Monday night in class.
That'll work.
Sounds good.
If you do not show, you get a 0.
So you better not be sick.
Get a car wreck.
Midterm, Monday night. And then I'll give y'all that extra night off to enjoy your spring break a little earlier.
My spring break on working.
You understand that?
I've got to work too. I got to prep for security commerce.
Oh yeah.
I know what I'm going to do for that. How many of y'all have security commerce with me?
Don't know.
One?
As he raises his hand hesitant.
He's shaking.
Anthony, you have it with me? So just 2? Oh, wow.
I had it last semester with me, so.
It's going to be different. All right.
So the midterms due the 10th.
Monday night. In class.